Hello, in this presentation, I will briefly explain my practical work 3, which focuses on document database and hierarchical data models using Mongo database. The main scenario of this project is called Aero Data Dynamics, and in this scenario, I worked as a junior data engineer who is responsible for migrating aviation-related data from flat files into Mongo database. At the beginning of the project, the data was stored in separate CSV and JSON files. This made analysis difficult and inefficient. So my first task was to import this data into Mongo database and organize it into collections such as airlines, airports, and flight logs. After importing the data, I noticed that many fields had incorrect data types. For example, dates were stored as strings and passenger counts were stored as strings, and latitude and longitude values were also stored as strings. And to solve this, I use update many with the convert operator to change these fields into proper types such as date, integer, and double. This step was very important because correct data types are necessary for accurate analysis. Next, I performed denormalization. I created a new collection called Flights Enhanced by using an aggregation pipeline. And in this pipeline, I used lookup to join flights logs with airport data based on destination IDATA codes. I also calculated a new field called flight duration minutes using the dateref operator. And this made the data easier to analyze and reduced the need for repeated joins. Finally, I performed several analytical queries on the flight's enhanced collection. These queries help analyze passenger counts, flight durations, and aircraft models, also destination stays. For example, I found aircraft models with the longest flights and stays with high total passenger numbers. These queries demonstrate how Mongo database aggregation pipelines can be used for complex analysis. Overall, this project helped me understand the advantages of document database compared to relational databases. Mongo database allows flexible schemas, nested documents, and efficient denormalized structures, which are especially useful for analytical and semi-structured data. So thank you for listening to me. This is my practical work 3 presentation.